Technology is hard.
Technology is extremely hard. And you know what? We're going to talk about that a lot. Okay, and we have sound, which is very good sign.
Both microphones?
Yes.
Excellent, come over.
I am coming over.
What a conference, and what an opportunity to go speak in one of my favorite cities in Europe, and to do a closing keynote on Friday at 4 o'clock. We're going to have to try to keep you guys awake. Are you guys awake?
Yeah,
okay.
no,
somebody
but you
over
will
there
be. But you will be. You will be, yes.
Before we begin, I think there's something wrong with this picture.
Yeah, no.
Oh, shit, this one is yours.
And this one is probably yours.
Ah, that's what was missing. Sorry, guys, 1 second.
All right.
All right.
So, almost there. Almost there. We just need to do, now we did the sound, now we do the video. We're almost there. Here we go.
Technology is hard.
Technology is annoying. We're going to talk about that, don't we? All right, here we go.
Clicker?
No.
No.
I mean, it's there, but yeah.
All right.
At the moment, no clicker.
I guess.
All right. So we have bad news for you all, people.
I'll click.
Yeah.
I'm sure you all heard that.
You definitely heard that. Who agrees, by the way, that we're all going to be fired soon?
Anybody? It's hard to see,
couple,
but yeah,
couple
not a lot, actually. People are pretty confident here.
Yeah, and it's a shame because they definitely will be.
I don't know, a few weeks ago, Satya Nadella said Microsoft writes 30% of their code with AI now.
And you might say, well, what a nice gimmick to sell more Copilot.
God, that thing, yeah.
But,
you know.
No, that's not the right slide. You shouldn't do that. You go away.
You do that.
Yeah, so, who heard about the layoffs at Microsoft the day before yesterday? 2,000 people out of the door. What is the connection between 30% of generated code and coders being fired?
Who knows?
Now, the thing is, it's definitely not just Microsoft. You can see the same headlines from other companies, IBM, CrowdStrike, and who's not. And you know what? Goldman Sachs just goes and says 300 million jobs are going to be replaced with AI.
And this is from like 10 years ago when we were 2 million short on engineers.
Yeah, a couple of years ago, definitely.
It's kind of crazy.
Yeah. So the scare is kind of real, right? And if you don't believe us, let's see how you are doing.
That's right.
Yeah, all right, go for it.
We have some questions for you, and you're going to answer them by raising your hand. It's okay to look around. If you don't want to participate, it's okay to opt out as well. Let's start with questions.
No, it's mandatory. We're going to punish people who don't vote.
All right. Who here uses an LLM for something on a daily basis already? Okay, it's interesting. It started from the front row. It's like you can see the propagation of
wave. Those are the early adopters here.
Oh, I see. That's why in the front row. Makes sense.
Yeah.
Okay.
So most of the people, right, uses it for work.
Who uses this for work? Left side of the room.
No, also right. Using it out of work. A lot
if you haven't tried it for travel planning, amazing.
Restaurants recommendation, recipes for cooking, what's not. All right, who actually use it to generate code?
Wow.
Yeah, no, that's a lot.
That's a lot.
Yeah, yeah. And those
the hype is real.
Yeah, those people are going to be replaced soon. Yeah, okay, all right.
Congratulations, all of you.
Yeah. If not code, what are you using it for?
Just shout it out. Give us good examples. You don't have to raise your hand. Shout it.
Large data parsing.
Okay, what else?
Yeah.
Code reviews. What else was that? Posters. Yeah.
Posters.
Sorry,
How
what?
about some T-shirts designs?
T-shirt designs?
Yeah, absolutely.
We can't see it.
Yeah, no. I'm not going to undress live on stage. We're not that desperate yet.
All right. When are you using it for code? Are you happy with the results? Who is happy with the results?
Like 5 hands?
Yeah.
Who is not happy with the results?
Who's going to like, it will be faster for me to do it myself. Yeah.
Yeah, all right, 95, 98%.
Pretty consistent.
Yeah. So
we talk to a lot of people.
Yes, and what we hear is that I will never trust code that I didn't write myself. Who can relate? Yeah, a lot of people can relate.
Who can tell me when was the earliest time this statement was used in our industry? Any guesses? 1950s.
So not today.
Not today. Not a new
1950s.
concept. Bonus points. Who knows who heard that for the first time in our industry?
IBM employee.
Possibly. Close enough. More
Fortran
specifically,
compiler authors, and the most noticeable of them is
Grace Hopper.
Grace Hopper.
Wow.
Okay, Tomer gets a t-shirt.
Tommy gets a t-shirt at the end, absolutely. There are t-shirts and stickers, by the way, for the right answers at the end. So Grace Hopper heard this in the 50s from assembly engineers that they will never try code. I heard it when I was starting in 2000s with Java. This whole Java bytecode thing will never be fast.
It's all magic. We have no idea how it works. We cannot trust.
It's a black box.
Yeah. All right, speaking about familiar quotes, how about this one? Right, so that, you all know it. That's from the 90s. That's allegedly, well, falsely said that Bill Gates said that. He didn't. But how it is suddenly relevant today?
Nobody's going to need a context window bigger than a couple K.
Whatever tokens there
Whatever
are
thing
now.
they measure that in. The interesting thing about all of those, if we look back at our industry, we've seen those headlines in the past. Between the two of us, we have over 50 years of experience,
Yep.
and we've seen it time and time again. I was early with SaaS and cloud, and we were told nobody's going to put your data in the cloud. But if you look at the trend, 50s, 60s, 70s, 90s, what you see is one common pattern that continues to emerge in our industry. And the pattern is, as you go through time,
We raise the level of abstraction. Take the control. I'm going to get the clicker. It's very annoying.
I know.
You can
We continuously add additional levels of abstraction. But the interesting thing that emerges is that abstraction, if wielded correctly, is a very powerful instrument that allows us to build better, more powerful, more complex, higher scale systems. I still remember waiting for a development server to be provisioned so I can deploy something, and now I can just go click on the Amazon UI and get a farm if I need to.
All right, hands off. We are cooking with clicker.
Thank God.
Now, yes, all those levels of abstraction and all those scares are very familiar. But this time, I claim that it is different. Not only this thing is unfamiliar and new and thus scary, this thing is scary because it does things wrong.
And the adoption of this stuff.
The joke is right here. You almost missed it. Look at the slide. Guess who generated it?
That's a ChatGPT slide. I can see one.
And that's obviously why it has a typo.
And why is that? The answer is pretty simple. Those systems are, by definition, stochastic. They have a degree of randomness introduced in them by design, and yet we're trying to get deterministic things like a piece of software that works correctly 100% of the time out of them. Those are the kind of results you're going to get out of the sentence every time you try a new prompt.
So same prompt, different results every time. And we want them to write correct, precise code.
There was a saying about that in the past.
This reminds me of this. You know the saying. An infinite number of monkeys with an infinite number of typewriters and infinite amount of time eventually will produce Shakespeare. And this is exactly what our LLMs are.
Except, instead of typewriters, we gave them GPUs.
And they're a little bit better than pure randomness.
Somewhat faster, and they're better, but they're still random.
But eventually, the idea is the same. You ask it to write Shakespeare. Most of the time, it won't. And then one
May
day...
sound like Shakespeare.
It might rhyme, but it won't be Shakespeare until one day it suddenly will, and then again it won't. And there is no way to know.
There is no way to know, but maybe there is.
All right, so I'm Baruch Sadogursky, at JBaruch everywhere on the internet. I'm the head of developer relations at a company called TuxCare that takes care of your open source security. We're hiring very heavily in Central Europe, so talk to us. I'm an abstraction connoisseur.
You mean you like to sample things a lot?
Exactly. As a developer advocate, I don't write production code, but I'm really interested in those samples. And obviously, LLM is the most spicy one those days.
Certainly brings the people To the talk.
Right, but to the yard, something. Yes, my personal journey is 25 plus years, starting from Java developer in one of the ways of the abstractions, going to DevOps, another way of abstractions with the company called JFrog, and now into this spicy new abstraction called LLMs. A Java champion, co-authored a couple of books, DevOps tools for Java developers, another two layers of abstraction together, and liquid software, which is an entirely different level of abstraction that we won't get right here. And this is...
My name is Igolnik. I lead engineering for a company called Clary. We actually have an office here, if you haven't been to our booth. We are also hiring, much like Baruch.
We are remote, you're in the office. We cater to every preference.
Between the two of us. I've been wrangling abstractions for my entire professional career. So I still caught the tail end of C development. I moved to Java in 2000, 2001. And then we'll be moving up the abstraction layer. And over time, because I love abstractions, I went from doing deterministic work with software to doing non-deterministic work with humans.
So between humans and monkeys, you feel pretty much at home with this
absolutely.
LLM stuff. Right? Yeah. The most important slide of this presentation is this. If you go to speaking.jbaruch with the dot between U and a C, thank you, Switzerland, for the top-level domain, you will find the slides already there. You will find a video that hopefully we are recording. I'm pretty sure we are. And all the links right there. You can scan the QR code, or it's also conveniently in the bottom of every slide, so you can just go and type speaking.jbaruch at any point of time. You want to ask questions, and you will scan this QR code. You'll get to like online system when you can type your questions in. And in the end of the talk, we will answer all of them, obviously.
And now let's go back to the question. Do you trust AI-generated code?
I don't trust AI-generated code. And more so, I'm right not trusting AI-generated code. By now, we already have studies that prove exactly that. Here's a couple of them. Evaluating code quality between GitHub Copilot, Amazon Code Whisperer, and ChatGPT. The results are horrible. 62, 46, and 31% respectively is just plain wrong.
I think a junior engineer can do better.
Absolutely, absolutely. And more importantly, and even scarier,
this thing hallucinates code confidently and with security issues. So it's great for the security vendors who will sell CISOs a lot of new software, but it's incredibly dangerous for production systems. And there are plenty of live examples already.
40% of the code it generates is vulnerable, and there is like an entire new vector of supply chain attack. It hallucinates more or less consistently. It keeps inventing non-existing NPM libraries, and people just create malicious libraries under their name, publish it in NPM registry, and then the code that hallucinated is going to download them and run them.
So you would say, what's wrong with that? Let's ask the thing to fix its own issues.
Oh, yeah. And if you ask it to fix its own issues, it will go exactly as you might expect it to go. It goes into a rabbit hole and makes it even worse every time.
So, to sum it up, unlike the movie where garbage produced power,
energy,
those LLMs consume a lot of energy, but seem to work in reverse.
We have inverse Mr. Fusion. We put in a lot of energy and get garbage out.
Now, I don't think you should despair. As we said, we've seen those abstraction layers come to our industry. We've seen the panic that they created. Who remembers that sysadmins will die and that's it? There's no more administration of any large systems. Good luck hiring a professional platform DevOps engineer today.
Oh, yeah.
The jobs do change, the abstractions change, but there's no reason to panic if you're willing to stay current.
Now, this one, as we mentioned, it's tricky. To wrangle it correctly, we have to do a lot of work, and this talk is exactly about how we can do it.
And by the way, we're not the only ones. If you look across the industries, healthcare, legal, HR, name an industry, there's some kind of AI psychic being built for them.
And as those AIs continue to hallucinate, understanding the system we are working with becomes more and more critical.
They're very productive. And perfect example of that, if you haven't seen it, a legal professional has used an AI assistant to submit a motion or a brief to the court where the AI very confidently hallucinated a non-existent precedent.
And it happened not only once, it happens multiple times. For example, just last week, it happened in Israel as well.
So without the expertise to be able to judge the output of those assistants, you won't be able to succeed to do anything meaningful with them. They still make errors. They do that very comfortably, but that's by design in their case.
So it's very clear now that AI is not minting expertise. It's the other way around. Your expertise is mandatory.
And they get amplified if you use the tool correctly. Now, if you're just early in your career, I wouldn't despair. Much like any new abstraction layer that is awkward and error-prone at the beginning, things mature in our industry. But the important thing is to realize that you either need to master those expertise regardless, or you already have to learn how to translate your existing expertise into the power of AI.
And we have a perfect example to illustrate you how important it is to understand the system that AI is working for. The system, the story goes like that. Someone asked an AI to speed up a JSON parser.
Things get slow, logical place to try, right?
It didn't work very well.
Well, one way of speeding it up is just take all the validation stuff out. Who cares?
It's actually faster.
Much faster.
Now, the problem is it should have been caught with the test that you obviously have.
Of course they did, but AI will take a passive least resistance. If you told it to go fast, it will see that the test started failing, and in some cases, it will take the test out as well.
It makes perfect sense. Removing validation is obviously an optimization.
That makes the code faster, right? That's what you wanted.
And now there is some pesky test that stands before us and this amazing optimization.
And I can't get to the success.
Well, what do we do? We remove it like humans, right? Anyway, this thing, when the AI matches the test to the code that it's written, even when the code is incorrect, it's called circular verification.
And a non-deterministic system, eager to succeed, is validating another non-deterministic system, eager to succeed.
They validate each other, and it's as bad as it sounds. We will need to fix that, and we will. What happened is that the prompt that we gave to the system, speed up JSON, was 100% implemented. JSON parser is now faster.
There was nothing wrong with the prompt itself.
So what is the problem?
The problem is ability to express your intent clearly and completely and in a comprehensive fashion. And the reason for that is what some books, and one of my favorite books on the topic called Made to Stick, calls the curse of knowledge.
Before we jump into that, it's natural for the juniors among us to struggle with expressing designs of complex systems in a clear way. If they know them at all, kind of hard to explain what you don't really grasp.
Sure.
But the problem is not limited to the junior engineers. Senior engineers, very knowledgeable people, have it the other way around.
They skip the obvious stuff, right? Like, of course, validation should be there. Of course, you don't remove the test when you make the code change, right? Why do I need to tell that? But that does not yet work with the modern system. And those of you that played the taboo game we had at the Clary booths will know that you know the basic words you're trying to describe, but describing those things clearly is incredibly difficult.
And the problem, it's not a problem for humans most of the time, especially when you speak to colleagues, because the colleagues have the same context.
Or they will give you the feedback loop of some kind. Hey, I don't understand, it's not clear to me. The machines...
And there is also obvious things, like removing validations you don't do.
That's right.
With the machines, you don't have that. They have no idea, and they will do exactly what you ask.
And there lies the problem with leveraging non-deterministic tools to achieve what we're all trying to achieve as a profession. We call it the intent to prompt chasm. We have a particular desire, but they're expressing it in a way that LLM will produce the result that matches our desire today without additional tools is incredibly difficult.
Let's see how we can bridge this chasm. One thing that you really have to have is obviously understanding the domain. Sometimes you cannot express what you know, but you definitely cannot express what you don't know.
That's right. And not just the domain, but also the abilities or tools that you have at your disposal to achieve certain things that you know will or will not work for a particular purpose. We call this combined world of knowledge is your deep domain expertise, whether it's the domain you're working on, the business domain, the application domain, or the domain of technologies.
And this knowledge enables what we call structured imagination. This is where you can imagine how the things will go if systems, deterministic or not, will go ahead with your expressed knowledge. How things will fail in the future, how they won't work, what can possibly go wrong.
Which brings us to the third pillar here, which is guardrails. Because we are dealing with non-deterministic systems, you have to put a boundary around the solution space to ensure that the system arrives at the desired output without taking the shortcuts you don't want it to take.
Guardrails are particularly critical for monkeys, for humans, and other non-deterministic systems like AI. And those three pillars build what we call the art of the possible.
So understanding the art of the possible, at least in our experience of playing with this technology, is the key to successfully leveraging those tools. So deep domain mastery, whether it's the domain of you as the technologist or whether it's the business domain in which you work.
It leads to structural imagination and envisioning what can go wrong.
And most important, setting up the right guardrails, where we'll spend a lot of the time for the rest of this keynote.
So, speaking about guardrails, when we speak about guardrails in software engineering, what is the first thing that comes to mind?
Anybody?
How do we implement guardrails in software engineering?
How do we set guardrails in our systems today? Tests.
Thank you very much.
Thank you very much.
Tomer just can come on stage and predict the entire keynote. Yes,
his LLM is clearly working.
We didn't pay him, though. Yes, obviously, tests are the expression of guardrails in software engineering. For them to be guardrails, they need to exist before we actually write code. Does it sound familiar to anyone?
Oh, yeah, it's okay, you can shout. It's hard to see the hands. Yes, we tried this at the industry once. I'm old enough to remember. There was, like, for a few years, TDD was all the rage.
What is
TDD?
Test-driven development is the idea that you write the test before you write the code. It has tons of benefits, like it gives you the confidence that what you actually wrote in the code is exactly what it was supposed to be, because TDD tests serve as a contract. They express what needs to be done, which is particularly critical for LLM, because if you remember, expressing the intent was the first challenge that we have.
Not only that, those tests serve a lot of other purposes. Majority of us work on code base we did not create. Isn't it nice to have an automated set of tests that tells us where we broke something or not, acting as a safety net for us? We need that safety net. The machines need it even more.
And now, if we have tests up front, reading those tests and comparing them with what we wanted serves as expression of intent.
I don't know about any of you here, but I did not get into software engineering to write tests. I got puzzled and intrigued by writing code because I had an idea, I could go write something, and I can see it in reality. And I think a lot of people in our profession are like that.
This is what we call biased for action, and this is all of us. We want to write code. When we have a problem ahead of us and we know how to solve it, we just go and solve it. This is one of the main reasons why. How many of you practice TDD actively day to day?
Like what,
5%? Exactly.
5%.
Exactly, right? And kudos for you who do. You have huge self-discipline respect.
Not only that, you have an advantage ahead of you by understanding this approach and how to leverage the modern AI sidekicks.
Exactly, exactly. Now, the solution for the problem that we don't want to write tests up front might be in a AI. AI can generate those tests for us automatically as we code and actually provide this discipline as a side effect of just going and doing the thing.
And that's a great benefit. Think about this. The code base that is developed like that continues to be covered by tests. And I have a project on my laptop that was done in that fashion. I have 98% code coverage without even trying, right? Which means then 3 months down the road when I come to that, I have the safety nets. And it builds that iterative loop of discipline that allows you to write this together with a bunch of other people and making sure you don't break things.
And this is very cool. The beautiful thing about it, that it can be actually, if not enforced, then at least suggested. AI agents like Windsurf Cascade and Cursor,
Junie,
GitHub
inside Copilot,
JetBrains,
maybe.
GitHub Copilot, and others, we can write rules and guidelines that will tell the agents what to do and not to do.
More like encourage.
Guidelines more than rules.
Yeah.
Yes, and this is definitely a good start.
So we believe that TDD is that first link in the chain that bridges the intent and prompt, but it's not enough.
Now, another reason why test-driven development never became a standard is because the second party that was supposed to be our companion in validating the intent through tests
were our friends in product management.
And business and design and everybody else who is not capable of reading tests.
How many of you have your product managers read your tests?
Yeah, no one.
Okay. Oh, there's one hand.
Oh,
We should talk after this.
Yes.
My product management team is here in the room. Please pay attention.
Do what they do.
We'll connect you.
Yep.
But realistically, product managers don't get into this profession to write this deterministic gobbledygook we code code. They want to be as creative and as expressive as the literature of Alexander Lamb.
So what they do know how to read is text.
They produce a lot of it, that's for sure.
Yeah. Now we'll get to that. But first, they read. And they read text in English, in Polish, in whatever. And there is another technique.
We tried this once.
That allows us to write the tests in almost plain language. Anyone?
BDD.
Exactly.
Much like TDD. BDD.
Who's practicing BDD? That's even funnier. Okay, two people.
Three.
All right.
We should send my product manager.
And Tomer, come on, Tomer. That's your, what's going on?
Also didn't take.
Boromir, whoever gets the joke. Yeah, so in any way, BDD, no one does it except Tomer and a couple of other people. But, and it's for a good reason. And that's the reason Leonid just mentioned. Product managers and other business people, they can read the spec correctly, but when it comes to writing this rigid spec of given, when, then, they feel constrained. Because, as Leonid mentioned,
creative personalities. What can I say?
They just write whatever they think that comes to mind.
So, the BDD met its inevitable end.
Yes.
Of the benefits never outweigh the hustle.
Because in the end of the day, if the product managers don't write it, and the developers have to write them themselves.
What's the point?
We are biased for action. We want to write code. No one wants to write spec just to become tests before we actually start to write code, because we want to write code.
And now the problem is getting even worse. Who needs any of this where I can just chat with my IDE? I can wipe code, I can express my requirements, and it writes code.
Exactly, exactly. It looks like we don't need it at all. But wait before we discard the strongly structured spec, because there is a huge benefit to this spec.
You can read it as a human, even though it's painful
not
to
only
write.
you, your product managers and business people.
Well, they're humans too.
Oh, really?
As I said, you can read it as a human. They're easy to read, they're painful to write, but the good news is we now have tools and techniques that allow us to write them and translate a basic set of requirements written in a narrative form to structured set of requirements as the first pass, and they're still in a form that is readable and readable efficiently.
The other side of it, that it's executable by machines. We don't need monkeys to go from spec to code, and this will become very important very soon.
So that brings us to the entire set of links that we believe today constitutes what we call intent integrity chain. How do you ensure that the original intent got translated into working software correctly without anything being lost in translation?
Let's break it down. This is how integrity chain works. Humans, including product managers, write prompts. We iterate together over those prompts until we are sure that it captured intent. This is free-form language. We do Stanislav Lem. We do whatever we want to do.
Shakespeare. You can write those in poetry.
In Shakespeare, absolutely.
Now, we give this, and we have the machine translate those free-form specs into a standardized, rigid set of requirements that are still English and English readable and understandable by mere humans.
Next step, once we have this rigid spec, which is readable by humans, but also executable by the machines generate the tests out of those specs. Once the tests are done, we let the monkeys loose and let them write code, type on those typewriters until we have Shakespeare.
Oh, Shakespeare validatable set of code.
This depends. How good the Shakespeare will be, Leonid, depends on how good your tests are, which depends on how good your spec are, which depends on how good your prompt are.
So for those of you that studied control system and manufacturing systems, if you have 20% error rate at any of those stages, the final output is about 60% accurate. Why? Because humans are stochastic.
They are.
LLMs are stochastic.
Monkeys are stochastic.
Right? And that brings us to a very important rule of working with LLMs.
This is intent integrity chain. We're talking about integrity. We're talking about validation. And the first rule of validation with AI is never trust a monkey.
Right? You have to constrain it. And we have an approach for you. Let's review.
Let's look at our chain and see what we can trust and what we cannot.
Should not, even. So let's start. First artifact in the chain is?
Prompt.
Form of requirements, right?
By humans.
By humans.
The requirements. And no validation really needed here because we just sit and discuss what we write. There is like nothing to validate.
Yep.
Next artifact is spec.
Yep.
Spec is written by monkeys. If it's written by monkeys, it cannot be trusted, period.
And we know that today, and that's why we have rituals like grooming, spec review meetings, and various other ways of ensuring the intent got translated into something we're going to give to a software engineer to implement. We do that today.
Next step is generating tests out of specs. This is done by monkeys, and it means that it cannot be trusted. But what if we had another way?
The other way is introducing determinism at that stage of the chain and take the monkeys out of generating the tests and ensuring that once you validated the English readable, human accessible desires in the form of specifications, the tests represent those things correctly.
Verifiably, algorithmically. And this is very important, and this is what, at the moment, Gherkin with Cucumber gives us, and tomorrow it will be another way of generating code out of spec. But the part that the spec is machine parsable means we don't need monkeys to go from spec to code. And this is critical. Let's go back to the list. We replace the monkeys in test generation. We now can trust it, and this is good.
And that's not a new technology. Been proven by use in real environments.
20 years.
Well, some people here use it.
Yeah, Tomer, does it work? Better than monkeys. All right, the last step is generating code. And obviously, as we spoke, code is generated by monkeys. That means we cannot trust it. And if we cannot trust it, we need, again, machines to help us.
Remember our example where the JSON parser got faster and the test got removed? How do we solve for that? We had another guardrail. Once we generated the tests, we logged them. We ensure that those tests can only be changed when we intend positively to change them. And by the way, logging can mean different things in different tools and frameworks. It could be as simple as just making the files read-only.
Absolutely. And this is a pure nature of TDD. You don't touch the tests while you write code. For humans, we just say, don't touch the tests. With monkeys, this won't work. They will touch the test unless you put the test in a cage.
Let's review again.
So
Artifacts.
now we can check that every stage in our chain is actually validated. Prompt, created by humans, validation not required.
They gathered the requirements.
Spec, generated by monkeys, and then verified by humans. Because spec is readable, we read through given when then, and we check that what we have in a spec matches our original intent. This is our beginning of closing the gap in the intent to prompt chasm.
And then we use the machine to generate the tests, and we use the machine to ensure that those tests pass when we're ready with the final set of the
we're
code.
not there yet. So test is generated by the machine and validated by the fact that those tests are generated without any variability, because it is compiled from spec to test. The last step is monkeys writing code, verified by the fact that the tests are read-only and cannot be changed. Validated by file system that enforces our read-only files.
One of the interesting side benefits from this approach is we get, in a way, a system that is self-documented, which allows us to create what we call a shared understanding and making that shared understanding of the system behavior executable.
And this shared understanding doesn't have to be in the form of those nasty specs that some people like, some people don't. We can ask monkeys to generate any kind of information between the prompt and the spec, because this is where the vulnerability between the intent and the prompt lives. And those documents are live documents that will eventually become executable once they become spec.
And the most important thing here is only the things that make it to the specs verifiably become the tests that can ensure the correct behavior of the system as we intended. And that's the only code that eventually will be written by LLMs because the tests
only what passes those tests will actually stay in the code. This is where Shakespeare is being written and validated all the way back now through the chain to the original question, if this Shakespeare or not, that we asked in our prompt.
So Bar, we've been waxing theoretically for like 40 minutes now, maybe 30, about those ideas. Does it actually work?
Surprisingly, it does. Surprisingly, because monkeys. We've been playing with the idea of intent integrity check for a couple of months now, and we did endless. Emma, I need to start and stop. So.
Well, you want to do? You do.
Yeah. So there is a surprising amount of work that is already actually happening.
So the demo we're going to show you is an IntelliJ's Junie, but I personally prefer windsurf. We've done this with Cursor, and the amount of tools that is emerging is just crazy. The concepts are the same, the underlying principles are the same. And
all right, let's
see.
I sped up the monkeys part, but we will stop as needed, and we'll see what's going on. Right, so here we go. We have a project that only have the guidelines and the prompt itself. And you can see the guidelines. Those are the intent integrity chain rules. We go into every step of the way, how the spec is generated from the prompt, how the tests are generated from the spec, and how the tests are immutable after they are done. You can see here exactly the locking rules, what is allowed to be touched, and what is not. And those are, you can see now exactly the stages of, and what to do in case of design errors and stuff.
If you remember those deep domain understanding, that's another example of how we express that our understanding of the domain for our particular project, and that's how we guide the LLM to execute it the way we believe the approach should be executed.
And now we have the prompt, which is again our expertise. We ask the LLM to create a simple to-do task. We provide some elements of the design. For example, I asked it to be in memory only, but most importantly, I asked it to adhere to our intent integrity chain methodology while writing. Let's see what happens.
Why in memory, by the way? What was so important to you here?
As with humans, monkeys have a hard time grasping complex systems. The simpler the task we give it, the better chance of success there is. Which is a very nice point to bring back another technology or methodology that we all love and hate. And that would be small pieces,
Micro.
something, something.
Oh, LLM completed my sentence. Microservices.
Microservices, of course.
I heard that.
Microservices become suddenly very, very important for two reasons. First, monkeys have a hard time grasping large, complex systems. Second, the Shakespeare that we get in the end will be probably pretty nasty in terms of quality of code. It will be complete in terms of functionality, functional, non-functional, because it has to pass the tests. But the quality of the code itself will be questionable. Do we want, when we need to change something, to go into this code and sieve through all the monkeys' output from different directions of the monkeys? We probably don't. What do we want to do? We want to write a new prompt. We might want to fix some specs, and then let it write it again.
All right, let us continue. So we gave the machine the prompt, and it started doing its thing. It's creating a documentation directory.
Yes, the docs is right there, and we're going to get into the docs and see what it does. So here is a system architecture document that describes data flow. Here are technical assumptions, speaking about not having database. This is our test scenarios. This is the beginning of the spec. From this, the spec will be generated. And this is plain English.
I can read that.
Ask your product people if they can.
I'm sure they can.
Now, ask them, come on.
Product people, can you? Yeah,
all right,
at least one could.
Good, all right, excellent.
All right, so
we're on track, we're on track.
So, and
do
this
you
is pretty
approve,
good.
as a product person, do you approve those scenarios? Product approved. Excellent.
We're going to need a seal.
Yes.
We can read it, and this is that beginning of the sharing understanding of how the system behaves, not just for the product people, not just for you, but for future teams that have to go maintain that.
Looking good. Product says it's good.
Here we go. We're approved.
Yep. Next, what will happen next?
Well, it's time to spec. Take the plain English from and make them a bit more structured.
Look, Gherkin spec. Here we go. All the scenarios. It's already passed, but yeah, they were definitely there.
They're there.
Oh, here they are. Here they are, all the scenarios. And yeah, and it's proper Gherkin. And Tomer has Vietnamese flashbacks from looking at that. as he should. But yeah, now we don't write them. How cool is that? We only read them. We read them together. And this is absolutely critical because this is where the gaps start to pop up. We ask something in our free text form, and now we see that the scenarios maybe missed something, maybe did something else. And this is exactly what happens in our demo. If we keep running it, you will see that we actually ask for a correction right here. If we run it. Yeah, here we go.
While the correction is running, this thing is
Look. Let's see what's going on.
Change the...
We discovered that we have something that we miss. After reviewing the spec, we identified one missing feature. And then we ask it to go back with the process, with the change process of intent integrity check and add new stuff.
While it's doing that, you may have noticed that everything here is also version controlled.
Absolutely.
So you have the full history of your shared system understanding. You have great commit messages, by the way. Those things are way better than any human I know doing this. And that gives you additional shared understanding of the system has evolved. Why did it evolve? What was missing? And what caused an introduction of certain requirements?
And because it is in Git, we can actually see diffs between what used to be and what's not.
So here we are. We're generating tests and making sure that all the scenarios are translated correctly from the scenarios into tests. Right?
This is the diff. That's what we asked to get changed. And those are all the new pieces that are getting added to our specs to make sure that now we don't miss anything. And yeah, it generates the test, and we will log the test, and we'll generate the code. In some point of time, it will start running tests, and it will have mixed success with the test, and it will keep doing it until it is actually a success. Here we go, fail test, and then more fail tests, and then eventually let it run. And then eventually we will see, yeah, still fail tests because monkeys. And boom, we got lucky, not yet. Are we?
Almost.
Almost.
There we go.
Ah, Shakespeare. Pure, like randomness, not pure, but a lot of randomness and variability in it, and eventually all the tests pass. Now, once all the tests pass, we know that all the specs are fulfilled, and specs were approved, so we're 100% sure that we have our integrity intact.
So we moved from the initial intent of building the to-do application through translating all of that intent into intermediate clarifying stages, verifiable stages that were deterministic, and then the final result.
It's exactly as we said in our table. Every next step is verified, either by machines or by humans. The monkeys are in check.
Not in charge.
Definitely not in charge. And you know what? We are not the only ones who are excited about prompting as the next level of abstraction. Andrei Karpathy is a pillar of our AI community.
That's right. Gave us Tesla autonomy.
Bunch of
key
other
member
stuff.
of early OpenAI.
And he was excited probably before any of us were in 2023, more than 2 years ago. And we want to add something to that. What you saw right now, the intent integrity chain, is not just about prompt. It is about intent alignment.
Starting with an idea, making that idea verifiable, making it shared, translating it into predictable deterministic tests, and then getting the code back.
3 things to take away.
We've been in this industry for too long to not realize that every abstraction we see starts with panic, whether it was move to Java, whether it's the move to the cloud, whether it's this move to AI where all the jobs are going to make tomorrow. Don't panic.
Mastery matters more than ever. You know all the individual contributors that didn't want to become managers because they need to deal with people who are not deterministic, terrible to manage, unpredictable feedback loops.
Variable feedback time things.
Yeah, both time and quality and all that. Me. Congratulations to me. Now we have to manage monkeys. And so, this is where mastery matters more than ever.
And this mastery applies to whether you've been in this industry for a long time, which is mastering the new tool and learning how to turn that into a force multiplier, or whether it's mastering, guiding this tool and learning the fundamentals of our industry without learning some of the basics of the mechanics of writing the code. I despise Python personally. I've never written a line of Python, and now I have 3 or 4 different useful projects written in Python because it seems to be the choice of Claude. And it doesn't matter to me anymore.
It doesn't matter to you because you don't manage code.
I manage the requirements.
Monkeys. Exactly. And as we said, particularly the intent integrity chain has a very powerful side effect of executable shared understanding. Those ridiculous Gherkin specs that everybody were too happy to get rid of suddenly play a central bridge between humans, monkeys, and machine. And is it like the best we can come with? Probably not. Probably not.
But we live in exciting times. These things change every other week.
And the idea that it's something that people can read and then machines can execute is more important than ever.
With that, would like to thank you. This is Baruch Sadogursky.
This is Leonid Igolnik.
But it would be a disservice to another collaborator of ours who worked with us on this keynote to not introduce them as well.
Do we have sound? We do have sound.
I'm thrilled to have been part of this project. Working on the intent integrity chain with you has been a fantastic experience, and I can't wait to see how it transforms the way we think about AI-assisted development. I'm really looking forward to seeing it make a big impact and help everyone build better, more reliable software. Thanks for having me on board.
Welcome, ChatGPT. In all seriousness, this keynote, including every single slide that you saw, would not be possible without an LLM. 8 weeks ago, those slides would not be possible without some modern tools that we just released. The intent integrity chain as a concept was synthesized out of the basic ideas that Baruch and I were working on as we were thinking about this keynote.
Yep. And obviously, speaking.jbaruch is where you go to find the slides, the video, all the links, everything we've been talking about, the video of the demo, the GitHub repository with a detailed description about what integrity chain is, how it works, so you can spread it around if you like the idea, and please do. And of course, with that, we have times for questions and what's not.
Let's see what questions came in.
Yes.
You need to move the thing to the thing.
Yes, I need to move the thing to the thing. Let's move the thing to the thing. This is how we move the thing to the thing.
I guess.
No, it's
second
not.
screen.
Second screen. How do I move this thing to the second screen? I have no idea.
You did it successfully in your last
I did, but not this time around. All right.
Drag.
I can drag. That I can do.
See?
Yeah.
Magic.
Dragging works.
And then there's a Q&A tab.
And then there is a Q&A tab. I think I'm on it.
I'll do it. I can see.
You can see?
Yes,
Yeah.
right there. Click.
And click. Oh, here we go. Perfect.
Full screen.
How do I do full screen?
The green thing.
The green.
All right. So the monkeys get to do the fun, creative stuff, writing code. We just validate the specs. Doesn't sound like a fun future.
Well,
I don't know. I had enough fun writing assembly code. And then I was told that, being a Java engineer back in 2001 is not being a real engineer. And yet, I think most of you here use higher level languages. I'm sure you will find an outlet for your creativity. I don't think the job of a software engineer will be constrained by just verifying the requirements.
You will write the pieces of software that you like, and you will let monkeys write the pieces of software that you don't like. This is perfect. This is actually much better than writing everything by yourself.
Yeah.
Yeah. How many years are left until Skynet Matrix really? I saw a very scary diagram the other day. It goes like the singularity graph starts with like the mice intelligence and then like dogs and cats and then what's not. The gap between stupid people, when we are right now on LLM level, to smart people, which is singularity, is that short comparing to the distance between mice and stupid people. Should we be worried?
I don't know.
I don't know.
How many years are left on?
Let's
say. If AI is not anything, why wasn't there big hype until recently? I would argue two things. Number one, as anything else was an industry, those abstractions end up building on each other. If there was no cloud, there wouldn't be an AI. If there was no internet, there wouldn't be AI because we couldn't gather the training data set. We couldn't scale the machines to train. Because those techniques, you're absolutely correct. The neural networks, they're not new. The Transformers paper is probably over 10 years.
Yes, but this is what I was going with that. There is a one pivotal moment that everything is accelerating from there. It's a paper from Google that it's called Attention is all you need. This is the point. This is where Sarah Connor, like Terminator, is going back to kill. That's that. That's attention is all you need.
But I think it's more than that. I think AI is moving much faster than a lot of other abstractions in this industry because it's now on everybody's mind. A lot of those abstractions that we showed at the beginning were internal to our business and our industry. Everybody knows what ChatGPT is now, right? So the humans and their imagination is there, and I think that's one of the reasons that the acceleration is happening much faster.
A very interesting question from Lad. Are some languages, human languages, better than others for prompting? There are two answers for that. The first is better in terms of cheaper, yes. There are languages that generate the same amount of prompt for less tokens. And the second point, much more interesting, is yes, depends on what language the model was trained on. The more training on a certain language, the better the results. This is why we do most of our prompting in English at the moment. In some point of time, other languages will catch up, and it probably won't matter anymore.
All right.
It's like Wikipedia, right? Different languages in Wikipedia provide different level of coverage. It's pretty much the same.
All right. Do you think this approach, does this approach works with an existing code base?
Okay, we really start to pay Tomer, I think.
I know. Interestingly enough, when Baruch and I were starting to work on this idea back in February, after he showed me some of his early work, I said, okay, that's interesting. Why don't we download the Spring framework Pet Clinic and try to attach to it? And we ran some experiments. We took Pet Clinic, and number one, we tried to reverse engineer test coverage. Without those guidelines, as well as without the guardrails, the machine invented quite a bit of new requirements for pet clinics. That was interesting. So yes, it does work, but you have to put some guardrails to ensure that the LLMs don't freestyle. It actually did quite well analyzing the test coverage for us, and it did quite well both implementing missing tests and allowing us to modify the code.
So let me go one level of abstraction up. Reverse intent integrity chain does exist. And it's a topic for an entire talk of its own, obviously. The most important part in it is an astonishing side effect. What it does after it discovers what needs to be covered with tests, covers it with tests, generate the specs, and then explain the specs to us, is that we can dig up intent out of legacy code. Think about it. It is priceless.
And at Clary, for example, we've recently deployed a tool called Factory.ai. There are many of them that compete on this, that analyze the repository and try to extract the intent, create pretty good diagrams, architectural diagrams, code flow diagrams. So yes, we believe, and we're going to continue to work on this idea, there is an opportunity for the reverse of this process that we showed you today.
Amazing question. Do you think people might stop learning and development if they rely too much on this tool? Could the result is a lot of deep insight into their domain? The whole idea of the art of the possible and the deep domain knowledge is that this tool not only be useless, but will actually be harmful to you if you lose domain mastery. Can you just play ignorant and say, you know what, AI is no better than I do? Probably yes. Will it serve you well in the end? Obviously not. Today, those are turbulent times. People have no idea how it works. Does AI mint expertise? Can we delegate expertise to AI? It's still unclear to a lot of people. For us, it's absolutely clear that this is the other way around. Only our expertise can keep the monkeys in check. And there is no way that without this expertise, something will work with, properly with the monkeys.
I'll just add to that something else. Baruch, did you stop learning when you stopped touching C?
Oh, I definitely didn't.
Did you stop learning when we stopped deploying physical service in the data center?
I definitely didn't.
Did you stop learning when you moved from coding to developer productivity thinking?
Definitely not.
So much like the industry, your abstraction levels continue to move up. Do you feel bored?
I feel very tired.
That's a function of jet lag.
It's also a function of age, but definitely not learning less.
In this approach, what would you do if you would find a technical bug in production? Let's source that answer from the room, because I think it should be obvious.
Go for it.
What do you do today if you find a technical bug in production? You reproduce it. Ideally, you write the test. And then, using the correct test, and again, with the reverse intent integrity chain, you can update the specifications. You have the machine implement the fix. Again, at Clary, we've been experimenting with Factory.ai. One of the interesting use cases I've been watching from some of our engineers for simpler bugs is actually point the tool at the Jira and start going from a description of the bug to Jira all the way for hot fixes. It's still fuzzy, but it works for very simple use cases already pretty well, and this stuff is moving incredibly well. I would do, if this was a code that was broken in production, the same thing I would do as a software engineer. That domain expertise is still valid. The approach is the same.
Going back to the previous question, right? And, all right, interesting stuff here. To safeguard core, there might be a huge amount of corner cases. Yes. Now, this goes back to the difference between humans as developers and monkeys as developers. We obviously need to guardrail humans less than monkeys, but it's a skill. Yes, we will have to think better about corner cases, and yes, we will learn how to do it. AI will help us in generating all those cases that we can check that have enough of corner cases, and if not, we will add more until it will be a second nature. It's just a muscle that we need to develop.
Good question. Have there been any improvements since 2021 and the paper that we cited on quality of LM outputs? Absolutely. The technology is evolving. The context windows are getting bigger. The models themselves are getting bigger. The only thing that hasn't changed is they're still stochastic, non-deterministic, variable output models. And therefore, yes, they will continue to improve, and specialized models will improve. So for example, Claude 3.7 thinking is better than anything else. Slower, but better in a lot of things because it's a better planner of executing the task. So it's starting to capture some of those domain expertise. But we haven't gotten to the point, only recently, I would say, within the last 3-4 months, what we have showed you in the demo became possible, let alone production quality.
Whoever asked about reverse it on point, that's exactly what we spoke about, so thank you, you nailed it. New programming languages that is suitable better for AI in general and intent integrity chain? Absolutely, for sure.
We have a tweet for that. It's called English.
No, but actually, everything else below English, both the spec and the language, those are the intermediate languages that we have between the prompt and the machine execution. None of them at the moment are tailored for that exact purpose. Not Gherkin, not whatever programming language our demo was, Kotlin or whatever. Will the tailored tools emerge and will be better in what we described? We definitely hope so.
I actually believe that because if the history of any indications, every time we found a new set of problems, we emerged with much more abstract way of doing things. Garbage collection to memory collection rather, memory management to garbage collection, right?
Yep.
So this industry, if you believe that it will continue to develop the way it's been developed, yes, something will emerge. Local models be advanced enough? Probably not, but I don't know if it matters. Any enterprise today can deploy a private instance of this model in your AWS account, in your Microsoft Azure account, in your GCP account. So sending your IP to a third party is no longer an issue because a lot of those models are available and you can go deploy them on your infrastructure if that's the requirement for you. Again, Clary, I'll use concrete examples. We use some Claude 3.5 sitting in the cloud. We have a private instance of Claude running as well. Our security team is using for their own internal purposes. So I don't think IP or security is going to be a big problem if you really want to use those tools.
Yeah, were our slides generated by AI? Duh. Obviously they were.
Every single slide outside of
the tables weren't. But
the tables were human.
Thank you.
Human curated.
Yes, artisanal
tables.
Yes.
Every single slide in this presentation was done by ChatGPT 4.0.
Yeah. What IDE supports running tests by AI in a loop? What about non-business requirements like performance, transactional? Great questions. You saw the demo running in Juni inside IntelliJ. We can do about the same demo with about the same results. It's monkeys, so there are variables, but eventually getting to Shakespeare, we did it
Windsurf.
in Windsurf Cascade.
I played it with Cursor.
And I played with Visual Studio, with Copilot and Agentic mode. They all work.
And they're all moving the same way. They're all giving you bigger and bigger set of rules files to put your guidelines and guardrails.
Those rules are being more and more enforceable to the level when we say, do not touch tests in those directories, we can be sure that they are not suggestions, but actually rules. Absolutely.
So we have not yet seen an IDE that we have tried where those principles couldn't work.
That's a very interesting question. Why do we need Java at all? Why won't we work directly with bytecode? As we spoke, those intermediate layers will probably converge, mutate, change, go away. We don't know what's going to happen. For now, the tools that we're using are those tools, and they are good. Why we use Java? Because we want to look at the sausage factory, we want to look at the monkey's pit and see what's going on there. Do we really need it? Can they generate directly bytecode? Maybe. That's an interesting experiment.
And they can. The problem is the current model that people pay hundreds of millions of dollars to generate are trained on available content on the internet. Nobody has, for now, spent the money to train the model specifically that goes from prompt to bytecode. Most of the models were trained on open source code and text from the internet, and therefore they go from prompt to some kind of language. And by the way, that's one of the reasons they prefer Python. A lot
of training was done on Python.
A lot of Python examples were used in entire. You have to remember, those things are just predictive machines. So if they were not trained on bytecode, which is absolutely feasible, they can't output bytecode.
What is the next abstraction beyond AI?
I hope we have at least 5-10 years before that comes. Number one, enough disruption in the industry. I don't know if we know. Do you?
I have no idea.
No idea.
So for now, we are at an uncertainty level like never before. One of the things that can happen is what if eventually monkeys evolve to have people capabilities, programming skills? And then either some of us who evolve become, instead of monkey wrangler, people manager, and those people live inside your machine. Or maybe the amount of garbage that learns from garbage will overwhelm everything, and we will see the end of internet, programming languages, and everything else.
The world as we know it. On that positive note, I think it's fine. It's time for us to close. As you go out, we have some stickers that we also used ChatGPT by feeding it the abstract and the outline of this keynote.
We also have some T-shirts that whoever deserves it knows it. So go and get your T-shirt.
Please ask the folks in the front. You'll get the T-shirt, whether it's the cool T-shirt over there.
Wait a second. I can undress.
Or the cool T-shirt over here. We have hats and other things. Thank you very much for listening on Friday. We hope you take something out of this.